Hi, everybody. Today I want to talk to you about systems of equations. Before we did linear equations, linear and a linear equation. Today we're going to mix it up a little bit and use quadratics as one of our equations. Okay, well, let's go back to first principles when we first started doing these systems of equations. If you recall, we were looking for the point where they intersect. That's where the two equations are equal to each other. That, of course, is that intersection point right there. Now, to find out with a linear equation, or two linear equations, we just set them equal to each other because the xy coordinate at that point is the same for both function f and function g. So the y values are the same and the x values are the same for both those functions at that point. So we'll just set them equal since y is 2x minus 5 and y is minus 5x plus 13. That means that these two equations are equal to each other. So that's exactly what we did. We set them equal to each other. We found x. Then we take this value of x, we plug it back into one of these two equations, your choice, whichever one is easier, and find out what y is. And it turns out when x is 18 over 7, y is 1/7, and that's that point right there. Now, we had three possibilities for our answers with these linear systems. We had one solution where there was one intersection point between the two lines, or maybe the two lines were parallel to each other. And in that case, there was no intersection point, no solution. Or maybe the equations turned out to have the same graph. In other words, they were the same. In that case, we have an infinite number of solutions. But now let's think about what happens when one of these equations is not linear. Let's take a look at when one of them is quadratic. Okay, so first let's think about what the possible solutions are. What possible outcomes could we get? Well, I could have a parabola that intersects with a straight line and get two intersection points, or maybe just one intersection point. And I'm missing my y-axis there for some reason. There we go. And perhaps I have no solutions. In that case, the linear equation completely misses the parabola. Okay, so let's do some of these by example. So I have a system right here. My first equation is x squared minus x minus 2, and my second equation is minus x plus 2. Both of them are equal to y. The transitive property says that we can set both of these equations equal to each other when we solve for x. We find out that the intersection points are where x is 2 and where x is negative 2. But we don't know what y is, so we have to plug those values back into one of the equations, either equation 1 or equation 2, to find out what y is. Now pick the easier of the two. It looks like equation 2 is the easier of the two. So when x is 2, I plug it in. F of 2, in other words, y when f is equal to 2 is 0. So one of the points is x is 2 and y is 0. The other point, when x is negative 2, y is 4. So my other point is negative 2 and 4. So we have two solutions, 2 comma 0 and minus 2 comma 4. Notice that the solutions are points. We need to give out points as a set of ordered pairs. It's a coordinate. It's on the coordinate plane, and it needs to have two numbers to describe it. Okay, a few more examples. Here's my first one right over here. And we have two equations, a quadratic and a linear. We set them equal to each other and we solve the quadratic. That was nice because we were able to factor. We get our two values of x when x is minus 2 and when x is 1. That's where the line intersects the parabola, but we need to find out the values of y. So I plugged x is negative 2 back into my equation above, found out y was 9, and I also plugged in x was 1 and found out y was 3. It turns out that those are my solutions. And just a quick little sketch of that first example is right there. We see our 2 points right here and right here. And this guy is x is minus 2, y is 9. And this one is x is 1, y is 3. Okay, our second system, let's take a look over here on the right. X squared plus x plus 3, and the other equation is y is negative x. So I set all these equal to each other and solve, turn my equation into a standard form quadratic, and now I have to factor. At first it looks like it's easy to factor, but it's really not. I know that A is 1, B is 2, and C is 3, so I can check out what kind of solutions am I going to have by looking at the discriminant. Don't forget the discriminant, b squared minus 4ac. If it's positive, you have two solutions. If it's 0, you have one solution. And if it's negative, you have no solutions. Well, it turns out that it works out to be -8, meaning that there's no solution. What that means is that there's no intersection point between the parabola and the straight line. And here's a quick sketch of that second example, and you can see that that straight line completely misses the parabola. Okay. Here's another example. Here's where we have a system where we have x squared plus 2x plus 5, and the other equation is minus 2x plus 1. We set the two of them equal to each other and solve the quadratic. We find out that that quadratic is a perfect square. We only have one solution where x is -2. Well, when x is -2, y is 5. So we have that one solution. And when we plot this, we get a parabola and then a line that comes down and only touches the parabola in one spot and then keeps on going. That line happens to also be called the tangent line. So there's our three examples. We had two solutions, no solution, and one solution. What I'd like you to do is to try to look over the review sections now at the end of chapter 9. We have to think about doing a test probably this week, I would think. And I would like you to look over problems 5 to 61 at the end of chapter 9 in that review section and pick 15 of them that you think are challenging and do them in your notebook. Also, get a hold of me if you're having any trouble doing them. We can communicate via Zoom or via email or however we can do it. I'm sure there's plenty of different ways. Office hours are Monday from 9 to 10. In other words, I'll be around. If you shoot me an email, I should be able to shoot it right back to you. Or you can invite me to a Zoom session, perhaps, if that's what you're thinking about, or get a hold of me and we can set something up. Anyway, if you do have questions, please feel free to shoot an email anytime, really. I know we have office hours, but that's kind of informal and they're flexible. And if you need to talk at another time, that's not a problem at all. Hope all's well with everybody. That's it for today. Take care.